All right, physics reaction video number 50. Big milestone. Today, I think I did a search for maybe honors physics. The thing is, when I search for these things, there's a ton that are just not in English. And so I'm not as capable of giving a lot of feedback. And so if I just look for like physics lecture or something, the titles will be in English, but the language might be, something else. And so that's a struggle for me. So I've started to use some words that tend to usually find English speaking videos. So I use the word honors or AP. Those tend to sort of do a little bit of a filter for me. But I'd love your help in thinking about ways to do better searches because, I don't need to only be reacting to the honors level physics. I could be just doing normal physics or ninth grade physical science or something. So that's what's going on there. All right, here we go.
All right, guys, so what we're going to do now is we're going to go and talk about series and parallel circuits based on your reading, and this is what I did in class, and I had the students go and tell me what they thought based off their reading before I gave them any notes. The first one that we did, it says a group of students built two different types of circuits in their science class. They wondered if the type of circuit made a difference in how brightly the bulbs burn. This is what they said. Carla said bulb A will burn the brightest. Margaret said bulb B will burn the brightest. Gwen said the first one in A will burn as bright as the bulbs in circuit B, but the second bulb in circuit A will be dimmer. And then Olaf said, I think both bulbs will burn the same brightness. And so in order to answer this question, because it says which student do you agree with and why, you need to first examine which type of circuit each one is. And when we look at this, A is a series circuit. They're all on the same path. And so what that means is if I disconnect this wire from the battery, both light bulbs will go out.
Just want to pause for a second and talk about how when I was sort of surprised when I first started teaching this that the students really didn't understand what was going on inside the bulb, right? That they thought it was some magical thing. It was like being plugged in was this magical thing. And so I'm often tempted to almost like break the bulb or show them a really, really simple bulb and really make it clear that, look, the wire just goes on in, it goes through some plastic casing, but, it's just basically a wire, and then it goes through the filament and then back down through. And, then, of course, it's like, oh, so any old wire will do this. Well, no, I mean, the tungsten filament is the one that has this magical property that if you heat it up enough, you can really see it. So I think that there's some subtleties there, but I'm just totally assuming she's past that now with these students, but I love this question. Such a great question. Battery, two light bulbs. As simple as you can go. The two simplest ways you could have a battery and two light bulbs. Though, of course, that could be a really interesting way to confuse students by putting this battery, sort of this leg of the circuit in between the bulbs. Similarly, you could put this battery right here, right? So I think that the prototypical ways that we present these two types, it tends to have the battery kind of way out here alone and then the two bulbs close together. So there's already some follow-ups that are going on. Love the fact that this is qualitative, right? It says just burn the brightest. It's not asking us to calculate exactly how bright it's going to be. I think we're supposed to assume all the bulbs are the same. Yeah, it doesn't really say, but let's go ahead and assume that all four bulbs here are exactly the same. So I think that was a really, really great question. And I love this one here. I think the first bulb in circuit A will burn as bright as the bulbs in circuit B, right? So what is the argument there? Well, this bulb has direct access to the battery. Just like this bulb has direct access to the battery, and this bulb kind of has direct access to the battery. It's weird though, right? Because this bulb has direct access to the battery on the other end. So it's really, really interesting if you compare and contrast how students respond to cartoon pictures like this versus component drawings where you draw, batteries with a couple of horizontal lines versus literally seeing it in lab. Very cool.
This wire from the battery, both light bulbs will go out. However, B is a parallel circuit. So if I disconnect this wire right here, the electricity can flow all the way back. And so that's one of the key differences between series and parallel. The other difference is that all the bulbs in A will glow more dim than they would be in B. And so Margaret is actually correct with thinking the bulbs in circuit B will burn the brightest. When you have a parallel circuit, If you add bulbs, they keep their brightness.
Mm-hmm.
In a series circuit, like in A, they're going to become more dim the more light bulbs you have on it. And so if you go and you watch the video that I posted yesterday for Mr. Bozeman,
Cool.
he talks about this and he gives you an example using a FET simulation.
Cool.
Going
That's
off
super
of
cool.
that, when we go to the next one, it's asking you to basically, and you can read it for yourself, rank them in order of the brightest to the dimmest.
So I love these ranking tasks, and I really am committed to trying to do more of them in my own teaching. There's whole books about ranking tasks that you can get, and that really sort of get the students to think, carefully about this stuff. When you first look at this, you're like, okay, there's 3 things. I'm supposed to rank 3 things, and you look at, what? There's 5, and it's the individual bulbs. Oh my goodness, right? But it's very clear that you can use the greater than symbol or the equal sign to do this. And so I think that these sorts of problems are super, super interesting. And did you hear how she really described the previous set? They should be ready for this. She certainly sort of distinguished these two. And so the question is, well, what kind of circuit is this, right? It's neither series nor parallel. And so it's really, really intriguing whether they would notice that, okay, A equals D equals E greater than B equals C, which is, I believe, the way you're supposed to answer this. But do students recognize this as sort of the beginning of a parallel circuit, or do they think of this as the beginning of a series circuit? And interestingly to me, sometimes people say, well, did you have to break the circuit to add more? So, if you go from the first one on the left to the one on the right, you don't really have to break the circuit. Imagine these were all bare wires. You could just clip here, and you're done. That's not breaking the circuit. In fact, you could add this one while this is lit if these were bare wires. It's kind of hard to deal with bare wires, but imagine we did, right? This one, to go from here to here, you couldn't do this without momentarily having B shut off. And so I'll talk about that, like logistically, how do you get there in the first place?
And so when we do this, we rank them from the brightest to the dimmest. We're going to need to look and say, okay, well, first, what kind of circuits do I have? This circuit right here, this one, A, is in light bulb A. This is a series circuit. It's just one.
Just a tiny little thing. Did you hear that, right? So she actually made the same initial mistake either I did or I almost did, which was to call this circuit A, right? She said over here in A, and immediately, think about what had to go through her head right there. I mean, it seems like a subtle thing, but it's an amazing series of thoughts, like, oh crap, there's B, C, D, and E. I better not call this circuit A because this is not circuit B and this is not, and right away she's like, actually it's the one with bulb A. So that kind of stuff, right, is what I am trying to empower teachers to think about how to do as smoothly as possible, not to avoid them. We can't avoid those situations, but man, that was super smooth. Let's listen to her do that again.
So what kind of circuits do I have? This circuit right here, this one, A, is in light bulb A. This is a series circuit. It's just one. There's not really series parallel. It's just one bulb. The second one is a series circuit. There's only one path for the electricity to go. And then in this one, it is going to be a parallel circuit. And so from the previous slide, we know that parallel circuits, both bulbs will burn at their brightest. So I know that D is going to equal E, which is going to actually equal A. Just because there is one bulb over there doesn't mean it will burn any brighter than the 2 that are in the parallel circuit.
Just want to pause here, right? So there's this moment in teaching this kind of stuff where you have to get to the internal resistance of the batteries. And so, especially, by the way, if you're using some of these bulbs that have pretty low resistances. So it's actually tough in lab to make this circuit and then this circuit and have the brightness literally be exactly the same. Though, let's be honest, very rarely do you actually measure the brightness. You usually just kind of go by, is it brighter or not, right? You're trying to do these sorts of comparisons. So, oh yeah, that's definitely brighter, and these two look about the same brightness, right? But because of the internal resistance of the battery, these two are working the battery harder, so it's wasting more energy, or I don't know, least is maybe not the right word, right? So I think that it's interesting that I love the way she's setting this up, and this is exactly the intuition we want to develop in our students. It's just frustrating that a couple of days later they say, oh, well, actually, batteries have this thing called internal resistance. Now that we know how to deal with circuits that have multiple resistors, let's now realize that all along we've had an extra resistor floating along with us that we kind of were ignoring. And so, my question for you guys is, how much does that make you feel like, oh boy, what I was talking to them last week is not quite true? So I always find that fascinating.
In fact, the voltage is going to be the same in each light bulb, and we'll get to that in a minute. Now, when we talk about B and C, they're going to burn the same brightness. So B and C are going to be the same brightness, but they are going to be more dim than the other three because they are on the series circuit. All right? We actually did not do this one in class. It got to be more complicated, so you can skip this one. This is the...
So I just want to pause and see what... Okay, so a little bit more numeric. Okay, but that was really interesting how she's sort of responding to the reality of her class, right? Like, well, yesterday we didn't quite get here, and she's thinking to herself, I don't want to confuse you with this, even though this is a very straightforward extension of what we've already been talking about. It's going to be better off for us to move on to the next stuff. So again, I love those critical decisions, and frankly, I just trust them. When I hear them from a teacher, there's always good reasons for these things. And to me, from a teacher prep and teacher support perspective, like, what do we do to help teachers be as good as possible? It's just to help them make decisions like this. There's never infinite time. There's never perfect situations. You know, yesterday doesn't always go as well as you had hoped or whatever. And so to make these kinds of decisions are, I think, super interesting.
Complicated, so you can skip this one. This is the link, and then we went into circuits. And so for a circuit, you need to understand that it needs to be a closed loop. If the electricity can't flow through the closed loop, it will not work. Electrons are always going to flow from the negative to the positive terminal. Work is done if there's resistance in the wire.
So I just wanted to pause here and say that this is an interesting example, right? So we've been doing light bulbs all along, and then you have this motor. Well, it turns out motors are complicated, right? All of a sudden you got to do magnetism and all of that stuff. But really, she's just trying, the point of this picture, if you read through what she was talking about there, is the flow, right? And so it's kind of teasing something else, like, oh yeah, I suppose you could put a battery on something that spins around. Maybe the students don't care about lighting light bulbs and they're much more interested in getting things to move. Yeah, no problem here. But you know, if you had a student, wait a minute, how does that work? Is a motor just like a light bulb? Well, no, it's just a bunch of wires. Well, if it's just a bunch of wires, how does it have any resistance? Well, there's this thing called inductance. You know what I mean? So that's tough. And so I think that's the interesting choices. Wait a second. We don't see the bottom of her screen. Why is that? Let me fix that. I didn't realize I was doing that. What I meant to do was this. There we go. Now we can see her whole screen. Okay.
And then we went and talked about series versus parallel. Well, here's a closed loop. Notice my closed.
So it's really interesting. It's not 100% clear to me if this is complete repeat of the day before. Like, is this just, hey guys, just a reminder what we were up to? Number one. Number two, is it, well, some people weren't in class, so let me catch them up. Or number three, hey, we did some cool stuff yesterday, and I want to gather that together, synthesize it, and maybe nudge you a little bit further down the path. She keeps using that phrase, so I'm not sure. But, you know, I would say it's accomplishing any of those three choices.
Switch right here. I can take the electrons and they don't have to cross a gap. They can cross all the way. So it will work. This will not work. There's no way for me to go from here to here. There's a big break right there.
You know, it's interesting, the schematic she's using where she's talking about the gaps that can happen, like the electron's able to make this path versus not. But it's interesting that this is shown as a gap, right? Now here it's labeled as the supply. So, you know, that's the battery, or that's the, the voltage supply of some kind. And it's unfortunate, right, that we all choose to do similar things. So she's trying to drive home this gap, and I love it. She's talking about, oh, well, the electrons weren't able to make it. But in the very same diagram, there's this gap. And so I actually think that that's problematic in sort of the physics world, right? And if you even think about like how batteries are drawn, they're drawn as gaps, right? They're kind of drawn like capacitors, sort of. So I don't know. It's something to think about for me.
All right. Going to the next one. Drawings of the diagrams. Okay, you need to understand all these parts, and basically this is saying how are you going to draw them, what they're going to look like. Then we get into two types of circuits. So you have a series circuit, which is only going to have one path. All the resistors in the series lie along a single path. The amount of current is going to be the same at all parts of the circuit. The resistance is going to change if they're added or taken away. And essentially, if you're adding light bulbs, you're going to get to here on the advantages and disadvantages. All right, advantages. The more components there are, the greater.
Cool. I like this. Sorry, this one just really caught my eye. Advantages, disadvantages of series circuit. Cost less to make. Oh, because there's less wires. Got it. Easier to make, no question. But man, you wouldn't want your Christmas tree or holiday lights to use series circuits. That's for sure. Because, as I say, yep, number one, and of course number three. Yep.
The circuit's resistance. It says there's less voltage going through each light bulb, making them dimmer.
By the way, when she was accelerating before, I'm guessing this is mostly just sort of like review notes because there were some really interesting diagrams and stuff that she skipped through. So again, just trying to figure out what this is for.
First disadvantage is if one breaks, they're all going to break. And then you need to understand the advantages. It costs less to make, and it's easier to make because it requires less parts.
Yep.
All right. So these are the advantages and disadvantages of a series circuit. Please make sure that you study these for your quiz. And then we went on to look at parallel versus series. So if I look at this, why parallel connection over a series connection?
Awesome.
Well, right here, there's a break in the wire. This break in the wire means all of them will go out. Because remember, we have to have a closed loop. It has to be a complete path. If I have this, it cannot flow all the way back. All right?
I just want to pause and talk about, we teachers do this kind of thing all the time. We'll do a search for an image that's really going to help us. And I really think this visual is really fantastic. It's just, I don't like the red here, but I wish this red was gone. But, well, so maybe I'm misunderstanding what red means. But anyways, I think this is a really cool thing. But do you see something that could really attract the eyes of the student? Like, what is this? This doesn't sound like a battery, right? Especially this. And so that's really, really tough because we work so hard to get them to understand these series and parallel circuits. We talk about batteries, and then they realize that almost everything they do in their life is AC. And what I've done is like, oh, it's the same, don't worry about it. When that's tough, right? Because, the poor electrons, the drift velocity is almost zero, so they don't travel, right? They just jiggle. And so I think that AC is a tough transition, but that's not why she has this image. This image, which comes apparently from electricaltechnology.org, has this beautiful description of series versus parallel. It just happens to have a label that's problematic.
Here it says parallel connection. It can flow all the way back. All right. So talking about parallel circuits, electrons in parallel circuit can travel through more than one path. Each path is separate. If one goes out, the others will stay on. In fact, if I draw one, just draw my own parallel with two light bulbs, light bulb, and then I have a battery down here.
Cool.
If I draw them like this, let me change my pen color. Yeah, I'll get the highlighter.
Cool.
And I want to, you know, this is one path. It goes from here to here all the way back. So there's one. Okay. And then I change it for the other one. Make this one green. It can go all the way back. And so what that means, if this is no longer there, it still has this yellow path to get all
Love
the way
that.
back to the other end of the bag.
So I really love that. I mean, I think that obviously there's a whole bunch of confusion with students about where are both of these things happening at once. Well, yeah, right. A lot of people jump to the plumbing analogy often with this, but I've just noticed that students don't necessarily have a lot of experience with plumbing. So this, I think, that was really, really cool. Um, Yeah, gosh, I think that this is such a hard topic, and I teach it all the time, and I'm just antsy to get to cool and interesting applications of it. But I just loved how she was very carefully talking about the advantages and disadvantages was really cool. I think that really trying to drive home exactly the differences, man, lots of really cool stuff. I think I'm going to stop it there. We're at 20 minutes or something. Um, so yeah, so questions that I guess I have are, how do you tease out or protect the students from internal resistance? How do you protect the students from AC stuff? Protect the students sounds weird. All I mean is, like, we want to develop this intuition that just gets busted when they realize that something completely different is happening in lab or in their lives or in their homes. But I really thought she did a great job of sort of hammering this stuff home. It seemed like it was sort of a review video, which, hey, that's fantastic. All right, everybody. I hope you have a great day. And remember, physics teachers are awesome.